Hello everyone, welcome to the webinar. We will start in a couple of minutes. I'm hoping that my screen is visible and I am clearly audible to all of you. Perfect. We'll wait for a few minutes and then we are good to start. Hello all, good evening, good evening. I'm hoping that you all are doing well. The session today is about subnetting. So let's wait for a few more participants. I think that people are still joining. So we'll wait for another 2 minutes and then we will start the session. Yes, Manjunath, don't worry. The recording will be uploaded on YouTube as well so that you guys can revise after all. All right, I see a lot of participants have joined in this amazing webinar, which is going to be about understanding subnetting from the very scratch. So I'm pretty sure that subnetting is something that sometimes people get confused about, right? Today, I'll try to bring clarity to your doubts. I'll try to bring you some understanding on how subnetting works, how it can be simply calculated to make sure that you utilize the network address spaces correctly. So, before we get started, a little about myself. My name is Chirag, and I am working with PyNet Labs as corporate trainer. So, talking a little about myself, my journey, the journey started from CCNA, then CCNP, CCIE, and now I am CCSI also. So, whenever we talk about networking, it basically starts from the very basics, and then gradually you can upgrade yourself and can reach up to some amazing technologies, can understand some amazing technologies, and reach the greater heights in the domain, right? Subnetting is something which is always there, be it CCNA, be it CCNP, be it CCI. I can say that because I observed it in all the exams, right? So it's a concept, it's a understanding that all of you should be very well aware of. You should understand it very nicely. And today we will try to get that for you. We'll try to understand how subnetting can be implemented, can be calculated easily with some procedures. So let's get started without wasting any time and let's understand what is subnetting, how to implement it. Before we talk about subnetting, I'll give you a quick introduction to the three classes of IP addresses that we use. In the IP version 4, we have got class A, class B, and class C for the public use. Class D and class E is also there, but these are reserved for certain purposes. Class A, Class B, and Class C, these are available for public use. Class D is reserved for multicasting, and Class E is reserved for research and development. So the only classes that we can work with are Class A, Class B, and Class C. So let's understand what are the IP ranges of these classes. Class A ranges from 0 to 127, in which the usable range is 1 to 126, because 0 is reserved for default IP and 127 for the loopback. Class B ranges from 128 to 191, and Class C ranges from 192 to 223. Class D goes from 224 to 239, and the final class, Class E, goes from 240 to 255. Like I mentioned, the only three classes that we can work with are Class A, Class B, and Class C. These classes are something that can help us in providing IP configurations to our different network devices. If I talk about class A, class B, and class C, all the networks basically, they are divided in two portions. One is called a network portion and the other is called the host portion. Guys, can you quickly let me know how many bits are there in IP address? 32, perfect. So for class A, the network and host bits division is like this: 8 in the network part and 24 in the host part. Similarly, for class B, it is 16 and 16. For class C, it is 24 and 8. This is the default distribution of network and host bits in all the three given classes. And as per the default distribution of network and host bits, we can also calculate the number of addresses a particular network can provide me from each of these classes. Number of addresses can be calculated by using a formula which is 2 raised to the power host bits. Okay. So for a class A network, the number of addresses are going to be 2 raised to the power 24, which means 16 million addresses, more than 16 million. Then for a class B default network, we'll have 16 bits in the host part, which will offer me 65,536 addresses. For a class C network, where we have 8 bits in the host part, there will be 256 addresses. So guys, subnetting is really important, and it's a process of creating multiple logical networks from a bigger or a larger network. Because it is not necessary, right, that I will always have a requirement of, let's say, 256 addresses, or I'll always have a requirement of 65,000 addresses. I might have smaller requirements as well, right? For example, I might have just a requirement of 50 IP addresses. So the lowest my class C can provide is 256. Subnetting is the process in which you break it down into smaller chunks and you use those chunks for your requirements, for your smaller requirements, like 50 addresses, 100 addresses, or let's say if I talk about class B, then probably let's say 1,000 addresses, 5,000 addresses. So subnetting is the process of breaking down a larger network into smaller chunks so that you can use one chunk for one requirement and the other chunks for the other requirements. Okay. For example, assume that you have an organization. Oops. Let's say this is the building of my office and there are different floors on it. On the ground floor, we have sales team having 50 members in it. On the first floor, we have the tech team having 50 members in it. And then let's say marketing team again having 50 members, and then finally HR team having the 50 members again. I don't want these different teams to communicate with each other. So what I can do is I can put them into different networks, right? If I put them into different networks, they'll not be able to communicate with each other, right? So let's say I went to the INA organization who is responsible for the allotment of IP addresses globally. I went there and I asked for some IP networks, and they offered me 4 class C networks, which were 210 1.0/24, 210 2.0/24, 210 3.0/24, and 210 4.0/24. Now this fulfills my requirement, which was basically that I want all the teams to be a part of different network, right? But along with that, it also does a lot of IP wastage. Why? By default, a class C/24 network is capable of providing me how many IP addresses? Let me know in the chat. 256, right? Out of 256, how much am I utilizing? Just 50. So there is a big wastage of around 200 IPs, right? And not just in the HR team, but also in the marketing, tech team, and sales team. So instead of using 4 different networks, I can implement subnetting and I can divide a large network. Let's say a large network of 256 addresses into 4 smaller parts of 64 addresses each. And I can give one part to the sales team, one part to the tech team, one part to the marketing team, and the final part to the HR team. So instead of getting 4 different networks, now I just have to pay for a /24 network, and I can provide IP addresses to the 50 devices of all the respective teams. This calculation, this procedure of dividing a larger network space into smaller part is what we call as subnetting. Make sense? This is where we understand how a bigger or a larger network space is divided into smaller chunks and can be utilized for different requirements as and when required. This is our purpose of this webinar, which we will try to get fulfilled by looking at some examples and understanding the process. But before we jump on to questions, before we try understanding the procedure of calculation, are we clear why do we exactly need subnetting? Let me know. Very good. Perfect. To manage networks efficiently, to make sure that we are not wasting IP addresses, we can implement subnetting. So let's learn how to do this. I'll take up a very basic and simple example first. We'll do it from class C. Gradually, we'll move to the complex questions. We'll try out class B, class A questions as well. From class C, let's say I have got a network which is 210.1.0/24. Okay. Originally, this network is capable of providing me 256 bits, right? Assume that I just have a requirement of 50 addresses. Okay. So for these 50 addresses, I will try to figure out how many host bits do I require. Right now, the distribution of network and host bits in this network is 24 and 8. Do you all agree with this? That's the default distribution, right? If I have 8 bits in my host part, how many IP addresses do I get? I get 256 IP addresses, correct? But if I use all the 8 bits for a requirement of 50 addresses, there is a wastage of around 206 IP addresses. Do you agree? So we will try to understand how many bits of host would be enough for 50 addresses. So what I'll do is I'll start counting the values starting from 0 bits. I'll put 0 as the power of 2. Why 2? Because we have binaries as zeros and 1, like bits are just 2. So that's why the base is going to be 2. 2 raised to the power 0 gives me 1. So that means if I keep 0 bits in my host part, I will just get how many IP addresses? Only one IP address. Then if I move ahead, I say 2 raised to the power 1. That's going to give me 2 as the value. So that means if I keep 1 as my host bit, I'll get 2 IP addresses. Moving ahead, 2 raised to the power 2 gives me 4. 2 raised to the power 5 gives me, 2 raised to the power 3 gives me 8. 2 raised to the power 4 gives me 16. 2 raised to the power 5 gives me 32. And 2 raised to the power 6 gives me 64, correct? What do you think? For a requirement of 50 addresses, can I say that 6 bits would be enough as it gives me 64 IP addresses? It will fulfill my requirement. Can I say that? Yeah. So that means I just need 6 bits out of the 8 bits. How many bits are extra? 2 bits. So I'll give this extra 2 bits to the network part. And my network part will be 26 and host part will be 6. Are we clear so far? Perfect. Now, as per this new distribution of bits, I will calculate 4 things. First, I will calculate number of IP addresses which will be there in my network. This can be calculated, like I told you, 2 raised to the power host bits. So as per the new distribution, we have how many bits in the host part? 6 bits. So 2 raised to the power 6, that gives me 64. Second thing that I need to calculate is number of networks. Number of networks basically means that if I start dividing my larger network into the parts of 64 addresses, then how many such parts will be there? Okay. Like if I am breaking down my bigger network space into smaller parts of 64 addresses each, then how many such parts can I create out of my network? This can be calculated by simply using a formula 2 raised to the power borrowed bits. How many bits are being borrowed here from the network part? I mean, sorry, from the host part to the network part? It's 2, right? So we can say number of networks are going to be 2 raised to the power 2. That means 4. Then third thing that we need to calculate is subnet mask. Subnet mask is the dotted decimal representation of network and host bits. Always remember, guys, that network bits in a subnet mask will be represented with 1 and host bits will be represented with 0. So as per the new distribution, there are 26 network bits and 6 host bits, correct? That means 1, 2, 3, 4, 5, 6, 7, 8. That's my first octet. 9, 10, 11, 12, 13, 14, 15, 16. That's my second octet. 17, 18, 19, 20, 21, 22, 23, 24 dot 25, 26. Because now, as per the new distribution, I have 26 network bits. And then host bits are 6. So 6 zeros. 1, 2, 3, 4, 5, 6. Make sense? Now we need to find out the dotted decimal form of this particular binary. So for calculating that, we have 8 values of my octet, which starts from 0 and goes up to 2 raised to the power 7. So 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 4, 5, 6, 7. These are the values of 8 bits that we have in our octet. 2 raised to the power 0 is 1. This is 2. This is 4. This is 8. This is 16. This is 32. This is 64. This is 128. Now we have to calculate what will be the dotted decimal form of this binary. So first octet contains all 1, right? I'll keep all of my bits as 1. 1, 1, 1, 1, 1, 1. Okay. When we keep all the bits as 1 or when we keep all the bits as on, what do we get the value as? What's going to be the value when all of our bits are on? 255. How did we say 255? Let's know. You simply add up all these values, okay? And you will get your results as 255. So 1 plus 2 is 3. 3 plus 4 is 7. 7 plus 8 is 15. 15 plus 16 is 31. 31 plus 32 is 63. 63 plus 64 is 127. And finally, 127 plus 128 is 255. So the maximum that I can get out of my octet is 255. So one thing is pretty clear that my first octet of the subnet mask will have the value as 255. If I look at the second octet, it is again all 1. So I can simply say 255. The third is also all 1. So that's also going to be 255. I need to find out the value for the last one, which has the first and second bit as on, but the remaining bits as off. So let's put the values here in the master formula. 1, 2, and then 6 zeros. According to this, we have 128 and 64 as the on bit. So I simply need to add them up, and this gives me 192. I can say the last octet will have the value as 192. Are we clear? Perfect. That's my subnet mask for the new network that I am creating, which is appropriate for 50 addresses. and will have a minimum wastage of just approximately 40 letters. Now let's look at the range. The final thing that you can calculate is range of IP addresses. My range will always begin from the first IP. The first IP is going to be 210.1.0. So from 210.1.0, I have to count 64 IP addresses. But let me say one thing. I have to count, let's say, 5 IP addresses. So from 210.1.0, if we are starting, what will be the next? I mean, what IPs will make it 5 IP addresses if we can count? Let me know in the chat also. I'm writing it here. I'm taking a simpler example here. We have 210.1.0 as the first IP. We have to count 5 IPs. So that's my first IP. 210.1.1 will be my second IP. 210.1.2 will be my third IP. 210.1.3 will be my fourth IP. 210.1.4 will be my fifth IP. These are the 5 IPs. Why are we ending at 1.4, not 1.5? Simply because we started from 1.0. Are we clear about this? Right? Keeping this logic in mind, can you guys let me know if I start counting 64 IP addresses from 1.0, so what will be the 64th IP? Can I say 210.1.63? Because again, we started from 1.0, right? So keeping that in mind, the 64th IP address will be 210.1.63. Make sense? So that's the IP range that I can use for my requirement of 50 addresses. Still, there is a wastage of somewhere around 14 IPs, but that's much, much, much better than wasting 206 IP addresses. Make sense? Here also, the first IP and the last IP is not something that we can use on end devices or any network device. We cannot assign them, as the first IP is used for representing the network and is called as network ID. So we cannot put this IP on any device. Similarly, the last IP is broadcast ID, which we use for sending traffic to all the devices of that subnet. That's my first range that can fulfill my requirement of 50 addresses. And the benefit of doing this is that I can create such 3 more ranges, which can again fulfill a requirement of addresses like 50 or 60 or 62. Yeah. So I can still use it for my different teams like sales team, HR team, marketing team. Any questions or doubts before we jump on to another example? Awesome, great. Are you finding it difficult? It's simple and easy, right? Perfect, great. So let's look at another example and let's try to figure out how we can do subnetting for that network. Assume that you are provided with 210.10.0/24 network, and this time the requirement is of not 50. 50 we have already tried. The requirement this time is of, let's say, 25 addresses. So I'll again explain you the process. It's very simple. First, you write down the default distribution of network and host bits. Okay. Then you need to figure out how many bits would be enough for 25 addresses. So 2 raised to the power 0 is 1, 2 raised to the power 1 is 2, 2 raised to the power 2 is 4, 3 is 8, 4 is 16, and 5 is 32. Can I say that 5 bits will be enough for fulfilling the requirement of 25 addresses? Yeah. So what I'll do is I'll subtract 5 and I'll find out how many bits are extra. There are 3 extra bits. I'll give those 3 extra bits to the network part. The new distribution will become 27 and 5. Clear, guys? Keeping this new distribution in mind, we have to calculate four things. First, we have to calculate number of addresses. Second, you have to calculate number of networks. Third, you need to calculate subnet mask. And finally, you need to calculate range. Number of addresses is 2 raised to the power host bits. So 2 raised to the power 5 bits. That gives me 32. Okay. Number of networks, 2 raised to the power borrowed bits, which is 3. So 2 raised to the power 3 gives me 8. This means that if I break down my chunks of 32 addresses from a /24 network, there will be how many smaller chunks? There will be 8 chunks. So I can fulfill requirements up to 30 addresses for 8 times out of my given network. Okay. So 2 raised to the power 3 gives me 8. Subnet mask now for 27 bits will be 1, 2, 3, 4, 5, 6, 7, 8 dot 9, 10, 11, 12, 13, 14, 15, 16 dot 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 0, 0, 0, 0, 0. Like we discussed, for this one, the value is going to be 255. For the second octet also, it will be 255. For the third octet also, it will be 255. For the last octet, where we have first 3 bits as on, let's see what will be the value by putting it in the master formula here. So the last octet of my question contains first 3 bits as on and the remaining bits as off. So if I calculate, it is 128 plus 64 plus 32. If you do the calculation, it will be 220. Yeah. So 128 plus 64 plus 32, that gives you 224. 8 plus 4, 12. 12 plus 2 is 14. 1 carried to the next one. Then 2 plus 6, 8. 8 plus 3, 11. Then 1 from the carry makes it 12. And then 1 again makes it 2. So 224. Subnet mask of my new distribution for the next requirement that we are addressing will be this 255, 255, 255 dot 224. Final part is calculating range. I'll begin from the first IP 210 10.0 to 210 10.31. Is that clear to all of us? If I count 32 IP addresses starting from 10.10.0, 10.10.31 will be my 32nd IP, right? Any questions or doubts here? Perfect. That's great. Amazing. Let's look at another example then. This time the IP network is 210.5.0/24. Okay. And the requirement is of 64 addresses. First of all, I'll write down my default distribution, which is again 24 in the network part, 8 in the host part, right? Now I need to figure out how many bits would be enough for 64 addresses. I want this time to you guys to try finding it out. Let me know how many bits would be enough for 64 bits. For 64 addresses, how many host bits will I require? Okay, I'm not asking how many bits will be borrowed. I'm asking how many host bits do I require, host bits do I require for 64 addresses. Okay, I can see some of you have mentioned 7, some of you have mentioned 6. 2 raised to the power 6 is 64. My requirement is 64. Doesn't that simply makes me fulfill the requirement? No. Why? Why no? Let's understand. Guys, we discussed that in the range, we cannot use the network ID and the broadcast ID. I require IP address for 64 devices. If I continue with 2 raised to the power 6, it will give me exactly 64 addresses, out of which the usable are going to be only 62 because the first IP and the last IP can't be used, right? So keeping that in mind, what do you think? Do we need 6 bits or do we need 7 bits to fulfill my requirement? Let me know again. We need 7, right? So those who wrote 6 earlier, is it clear that why do we require 7? Perfect, great. So we will continue the question with 7 bits as required. I'll subtract 7, 1 bit is extra. I'll give it to the network part. Network part becomes 25. Host part is going to be 7. With this particular distribution, we will calculate the 4 things. Number of addresses, which will be 2 raised to the power 7, 128. Second thing, number of networks. Let me know how many networks will I be able to create if the part is going to be of 128. 2, right? Because the borrowed bits are 1, that's going to give me 2. Okay, we have a question here, a quick question. What does that mean? Slash 24 slash 32 slash 26 or whatever. The slash value is the CIDR information, which represents the network bits, Tushar. So whenever I say slash 24, that means I am telling you that 24 bits are in the network part. And because 24 bits are in network, so you can simply understand 32 minus 24. 8 bits will be in the host part. Make sense? Is that clear to you, Tushar? Yes, that's the CIDR notation. CIDR stands for classless interdomain routing. Perfect. Moving ahead, number of networks are calculated. Now we'll calculate subnet mask. Subnet mask, I need to calculate for how many bits? 25 bits. So first 3 octets will be 255.255.255 for my first 24 bits. And the last bit will be, last octet will be 1 and 7 times 0. If I put it in the master formula, it will be 1 0 0 0 0 0 0 0. So what I'll get the outcome as? I'll get the outcome as 128, correct? Because I'm just keeping the first bit as on. So my subnet mask will become 255.255.255.128. Then I need to calculate the range. Again, my range will begin from 210 5.0 and will end at 210 5.127. Clear, guys? That's the first part of the network. But we discussed that we can create how many networks? 2. So can you let me know in the chat what's going to be the second part? Definitely, I can explain how to calculate subnet mask again. So Jainam, just let me know, are you clear that how this new redistribution is being calculated? I mean, how the new distribution of network and host bits is being calculated. Are you clear with that? Awesome. I told you that network bits are represented with 1 and host bits are always represented with 0 in a subnet mask. Okay. So we have got 25 network bits and just erase this much. Yeah. So we have got 25 network bits and 7 host bits. That means 25 times 1, 1, 2, 3, 4, 5, 6, 7, 8 dot 9, 10, 11, 12, 13, 14, 15, 16 dot 17, 18, 19, 20, 21, 22, 23, 24 dot 25 and then 0, 0, 0, 0, 0, 0. 7 times 0. Clear? Now this will be 255 because all the bits are on and the maximum I get is 255. This will be 255 and this will also be 255. I need to calculate the value for the last octet where I have the first bit as on, which I'll do simply by putting in the 8 values. These values are for the 8 bits of your octet. Okay. So if I calculate this 10000000, what will I get as the outcome? I'll get 128, right? Because we are just keeping that bit as on. So pretty simply, I'll write down that my last octet will have the value as 128, and that makes my subnet mask. Clear? Then yeah, the range, the first range will be 210 5.0 to 210 5.127. And my second range will be 210 5.128 to 210 5.255. Are we good with the class C subnetting questions? That's great. I'll give you one question to try by yourself also, so that we can understand if we have actually learned something or not. A very simple question. 210 1.0 is the provided network /24, and the requirement is of, let's say, uh, the requirement is of 12 addresses. I just want you to tell me what will be the subnet mask and what will be the first range. Just calculate first range, not more than that. Just tell me what is the subnet mask going to be and what will be the first range for my 12 addresses. I can see your responses. Very good job. I didn't expected you guys to do it that quickly. So this really means that you are learning it well. Good job, everyone. Because we require 12 addresses, so I'll simply go for 2 raised to the power 4, which gives me 16 addresses, right? And then if I have 4 bits in my host part, the network part is going to be how many bits? I can say 28 bits, for which for 28 bits, my subnet mask will be 255.255.255.240. Let's see how. For the first 24 bits, we should be clear that it's going to be all 11111, right? For the last octet, because it is 28 bits, my binary will look something like this. This is going to be the 25th bit, 26th, 27th, 28th. So the value for this will be 128 plus 64, 192. 192 plus 32 is 224. 224 plus 16 is 240. That's how the value of last octet is coming, which is 240, and my range is simply going to be 210.1.0 to 210.1.15. Good job, guys. Okay. I think we all are very well aware now how class C subnetting works. Let's jump on to class B and understand it with a good number of examples. Now we have class B network 150.1.0.0/16. Okay. And the requirement is of now, let's say 500 addresses. Okay, many people get confused with a higher requirement. I'll give you very simple trick and you will understand it very easily how you can do it very simply for class B and class A as well. We have got a requirement of 500 addresses. We will follow the same procedure that we have followed in class C. I'll calculate first of all the number of bits that I require for 500 addresses. Okay. The default distribution of network and host bits is 16 and 16 this time, correct? Yeah, sure. Before we proceed ahead, we have a question here about the range. So guys, we had a requirement of 12 addresses, and if you count from 2 raised to the power 0, it is 1, 2 raised to the power 1, it is 2, 2 raised to the power 2 is 4, and 2 raised to the power 3 is 8. So none of that fulfills my requirement, but 2 raised to the power 4 is 16, which fulfills my requirement, right? Clear, John? So for 16 addresses, if I start counting from 210.1.0, my 16th IP will be 210.1.15. Make sense? Awesome. Now for class B, we were looking at a network where the default distribution is 16 and 16. 16 bits in the network part, 16 bits in the host part. My requirement is of 500 addresses. I need to figure out how many bits would be enough for 500 addresses. I'll start from 2 raised to the power 7, which is 128, correct? 2 raised to the power 8 is 256. 2 raised to the power 9 is 512, which I think can fulfill my requirement, right? Out of 16, I require 9 bits. How many bits extra? 7 bits extra. I'll give it to the network part. Network part will become 23. Host part will become 9. Again, the 4 things I need to calculate: number of addresses, 2 raised to the power 9, 512. Second, number of networks, 2 raised to the power 7, that is 128. Third, subnet mask. Let me know quickly what will be the subnet mask for 23 bits. For 23 bits, we can say 1, 2, 3, 4, 5, 6, 7, 8 dot 9, 10, 11, 12, 13, 14, 15, 16 dot 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, right? This is 25, 255. This is again 255. This is going to be 254. And this is obviously going to be 0. How is this 254? Let's quickly have a look on the master formula. We are keeping all the bits as on except the last bit. The last bit is what? 1. So 255 minus 1 gives me 254. Clear, guys? That will be my subnet mask. Now for calculating range, As per the logic that we have implemented earlier, my range will be 150.10 dot, yeah, 150.1 dot 0.0 to 150.1 dot 0.511. But wait a second, can I have a value greater than 255 in my octet? No, I cannot, because there are only 8 bits in one octet. I cannot have a value which is higher than 255. So what to do in this case? In this case, we will make the change in the third octet. To figure that out, what I will do is I will divide my number of addresses by 256. If I divide 512 by 256, I get 2, right? This tells me that I need 256 addresses 2 times to fulfill my requirement of 512 IP addresses. That means first I will need IP starting from 151.0.0 to 151.0.255, then 151.1.0 to 151.1.255. And when I combine them together, I can fulfill my requirement of 512 IP addresses. So combinedly, if I write it, it will be 151.0.0 to 151.1.255. That's the combined range. Are we clear about it? This range of mine will help me to connect 512, I mean, not 512, to be precise, 510 network devices under the same network. Let me know if you have got questions or doubts in this. I'll give you another example, no worries. What we did is we got a number greater than 255, right? So it's pretty clear that if we have got the maximum here, the next IP after this is going to be 150.110. Do you agree? Because I'll have to make a change now in the third octet as I have reached the maximum of my fourth octet, correct? So I did the division to figure out how many times do I need 256 addresses. I required it 2 times. So my first set of 256 addresses will begin from 1.0.0 and will end at 1.0.255, correct? Then the second network, or we can say the second set of 256 addresses will begin from 151.1.0 and will end at 1.1.255. Now, because my original requirement is of 512 addresses, so I combined them together and I made a combined range, which is this. Okay, what will be the network ID here? Network ID, as I discussed earlier, will be the first IP, and the broadcast ID is going to be this IP. Guys, we have to understand one thing. We don't have 2 networks here. No, we just have one network, which is this. I did this breakdown to make you understand. That's it. It is only one network where network ID is the first IP, broadcast ID is the last IP. Clear? Shall we look at another example? Yeah. Another example here for people who couldn't understand it last time. Let's pay attention now again. We are again provided with a similar network. I'm taking the same network /16, and the requirement this time is of 1,000 addresses. Okay. The default distribution of network and host bits will be 16 and 16, correct? I need to figure out how many bits would be required for 1,000 addresses. So 2 raised to the power 7 is 128, 2 raised to the power 8 is 256, 2 raised to the power 9 is 512, 2 raised to the power 10 is 1024. The trick is that every time you just have to double the value. Okay. So 512 is for 2 raised to the power 9. 2 raised to the power 10 will be 1024. Can I say that 10 bits will be enough for fulfilling my requirement? Yeah. So I will subtract 10. 6 bits are extra. I'll give that to the network part. The new distribution will be 22 and 10. First thing I need to calculate is number of addresses, which will be 2 raised to the power 10, 1024. Second thing I need to calculate is number of networks, which will be 2 raised to the power 6, which is borrowed bits, going to be 64, right? Third thing, subnet mask. Subnet mask I need to calculate for 22 bits. So for 22 bits, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 0, 0, 0, 0, 0, 0, 0. This will be 255. This will be 255. This will be 0. What will be the value for third octet? That's going to be 252. Perfect. That's my subnet mask. Finally, it's time to calculate range. For calculating range, I will divide it by 256. I get to know I need it 4 times. That means 150.1.0.0 to 150.1.3.255. 0.0 to 0.255, 1.0 to 1.255, 2.0 to 2.255, and then 3.0 to 3.255. If you combine it together, it becomes 0.0 to 3.255. In this case, the only network ID is this one, and the broadcast ID is this one. So let me know, what do you think? If I try to apply the IP 150.1.1.0 on some PC, will I be able to configure that IP on a PC? Is it a usable IP? Guys, it is a usable IP. Why is it not usable? It's a part of my range, right? I said the first IP is network ID, the last IP is broadcast IP. Only these two IP we cannot use, but anything which is between this range is a usable IP. So every IP starting from 150.1.0.1 up to 150.1.3.254 is usable. So this is your usable range. Make sense? So definitely 150.1.1.0 is a usable IP as it is a part of the range. It's not the first IP, it's not the last IP. Clear? Okay, Naveen, let's understand the range part again. We have to calculate range for how many addresses? 1024 addresses, correct? My range will begin from 151.0.0 and will end at 151.0.1023. But we are pretty sure that 250, more than 255, we cannot have any value in this octet, right? Do you agree? Yeah. So I need to figure out what change do I need to make in this octet so that I can fulfill my requirement. To know that, you can divide it by 256, you'll get 4. That means you need 256 addresses 4 times to fulfill your requirement of a single network having 1024 addresses. Okay. So 256 addresses 4 times means that first you will start from 0.0 and you will end at 0.255. This is your first 256 addresses, correct? Then you will again move ahead from 1.1.0 to 150 dot, yeah, 150.1.1.255. These are your next 256 addresses. Then 150.1.2.0, 150.1.2.255. These are your next 256 addresses. 150.1.3.0 to 150.1.3.255. These are your next 256 addresses. If you combine them together, you will get a complete range of 1024 addresses, which will start from 150.1.0.0 and will end at 150.1.3.255. What queries or doubts do we have? Ragwinder, we can definitely do the same thing with the IP network 192.1.00 if a /16 network is provided to us. No difference will be there, nothing, no difference at all. So exact same thing can be used with 192.1.00 as well. Same calculation, same results. It's just that the range will have 192.1.0.0 to 192.1.3.255. Anyone else having any other questions? Are we clear so far? Give me a yes or no. Are you guys excited to try one question by yourself? Cool, then I'll give you one to try also, and we'll speak about solution of it then. The question is, let's go for the one that you mentioned, 192.1.0.0 network /16. Okay. And your requirement is 2000 addresses. Again, you just have to calculate subnet mask and the first range. Yeah, I was saying good job, guys. We have already got the responses. Perfect. I'll let you guys try completing this by yourself first, then we'll speak about the solution here. Okay, let's look at the solution. For 2000 addresses, 2 raised to the power 10 was 1024, right? 2 raised to the power 11 is going to be 2048. So 2 raised to the power 11 will fulfill my requirement. The default distribution is 16 and 16. I'll subtract 11 out of it. 5 bits are extra. I'll give it to the network part. Network part will become 21. Host part will become 11. Keeping that in mind, we will calculate the four things. Number of addresses, which will be 2 raised to the power 11, that is 2048. And if you divide this by 256, you will get 8 as the outcome. Number of networks, 2 raised to the power baud bits, which is 5. So 32 such networks. Subnet mask for 21 bits will be 255.255 for the first 16 bits. For the next 5 bits, it's going to be 248 and then 0, right? And finally, the range. Range will begin from 192.1.0.0 and will end at 192.1.7.255. Are we all clear about this? Yeah. Then finally, I'll also show you one example of class A network as well. Again, the method is completely same for class A. The calculations will become a little, we can say it's going to get a little larger because the address space is going to be bigger. So class A network offers us a /8 network. Let's assume we are provided with 1.0.0.0/8 and the requirement is of 100,000 addresses, 1 lakh addresses. So the default distribution, guys, is what? 8 in the network part, 24 in the host part. I need to find out what number of bits would be enough for 1 lakh addresses, right? Or the 100,000 addresses. Tell me 2 raised to the power 16 is what? We discussed it in the beginning, right? 2 raised to the power 16, which is a class B network, it offers me how many IPs? 65,536 IPs. So for 1 lakh addresses, I will begin counting from 2 raised to the power 16. 2 raised to the power 16 is 65,536. What's going to be 2 raised to the power 17 then? We'll double this. 12. 2 multiplied by 3 is 6 plus 1, 7. 0, 11, 13. 131072. Okay. 131072 definitely fulfills my requirement of 1 lakh addresses. So I can say out of 24 bits, how much do I require? I require just 17 bits. How many bits are extra? 7 bits are extra. I'll give it to the network part. New distribution will become 15 and 17. First thing I need to calculate is number of addresses, which will be 2 raised to the power 17, which is 131072. Second thing I need to calculate is number of addresses, number of networks, which will be 2 raised to the power borrowed bits, which is 128. Third thing is subnet mask. Let me know, guys, what will be the subnet mask for 15 network bits. We have got it already, 255.254.0.0. Those who cannot understand this, just write it in binary. 1, 2, 3, 4, 5, 6, 7, 8. Dot 9, 10, 11, 12, 13, 14, 15, 16. Dot 0, 0, 0, 0, 0, 0, 0. Dot 0, 0, 0, 0, 0, 0, 0, 0. So this will be definitely 0. This will be definitely 0. This will be 255. And if we do not consider the last bit, the value we get is 254 as the last bit is 1. That's going to be my subnet mask, right? Finally, it's time to calculate range. For calculating range, I will divide this number by 256. I want you guys to calculate this and let me know in the chat what do you get as the outcome. If you divide 131,072 by 256, you will get 512. But that's again a number which we cannot fit in any octet. Do you agree? Earlier also we had this problem. So we decided that we will figure out what number of change would be required in the third octet by dividing it by 256. Now we again are in the same problem. I can simply say that I need 256 addresses 512 times. But 512 is not a number that I can fit in my octet. So I will divide 512 again by 256. What do I get, guys? If I divide this number 512 again by 256, what will I get? 2. So can I say that instead of 512 times, I need 256 addresses, 256 multiplied by 2 times, which is also, if you calculate just this part, it is also 512 only, but written in a different manner. Do you all agree? Yeah. So we simply have to divide it again to know basically how much change I need to make this time in the second octet. The first time you divide is you realize what number of times you need to change the third octet. But when you divide it again, you are trying to figure out what number of change you need in the second octet. So now I need it 2 times. That means my range will begin from 1.0.0.0 to 1.1.255.255. If I break down this range for you, it is 1.0.0.0 to 1.0.255.255. These are 256 multiplied by 256 addresses, which is also 65,536 addresses. Okay. Then I need a similar range, which will begin from 1.1.0.0 and will go up to 1.1.255.255. This is again 256 multiplied by 256 addresses and are again 65,536 addresses. So if I combine these two ranges together into one and write it together, so that's my original range for 131,072 addresses. What questions or doubts do we have in this? Are we clear about how class A subnetting questions can be done? I'll show you one more example to make it more better. Let's assume we are provided with the network 8.0.0.0/8. The default distribution is 8 in the network part, 24 in the host part. Assume that now we have a requirement of 200,000 addresses or 2 lakh IP addresses. Okay. So 2 raised to the power 17 gave me 131,072. I'll calculate 2 raised to the power 18 now, which will be 4, 14, 1, 2, 6, 2. 262,144. I'll just cross check on my calculator. 131,072 multiplied by 2. Yeah, 262,144. This fulfills my requirement, right? So that means out of 24 bits, I need 18 bits. 6 bits extra, I'll give it to the network part. Network part becomes 14, host part becomes 18. Number of addresses, 2 raised to the power 18, 262,144. number of networks. 2 raised to the power 6, gonna be 64. Subnet mask. What's gonna be the subnet mask for 14 bits? 255.252.0.0. Final range part. For range divided by 256, let me know what do you get. 1024. Now, because this number is again greater than 255, I'll divide it again by 256. I'll get 4. So I got the number which I need to modify here, or which I will have to, or we can say we will need the change in the second octet 4 times. So I can say my range will begin from 8.0.0.0 and will end at 8.3.255.255. So this outcome of 4 tells me that I need 256 multiplied by 256 addresses 4 times. So that's my range for that, which will help me to assign IP to 262.144, 144 devices. Does that make sense? So this time you are just dividing it twice to know what change you require in the second octet. Ravi, you had a question in range. Is it clear now? I'm glad that you guys liked my explanation and you got to know about subnetting through this particular webinar. I'll explain the range part again. For calculating range, we have to divide the number of IP addresses by 256. As we got a number greater than 256, we divided it again. We got the value as 4. As we got 4, this brings us the clarity that 4 times change is required in the second octet. Okay. So that's why my range will begin from 8.0.0.0 to 8.3.255.255, which actually accommodates 8.0.0.0, 8.0.255.255, 8.0.1, sorry, 8.1.0.0, 8.1.255.255, then 8.2.0.0, 8.2.255.255, and 8.3.0.0 to 8.3.255.255. Clear, guys? Definitely, Ashraf, if you calculate it through the same procedure, it's going to be very easy for you to find out the solution for your subnetting related concerns and questions, right? And guys, subnetting is not just the only topic that can help you become an expert in the networking domain, but it is definitely a topic like which goes through your journey. Like I told you, I did CCNA, CCNP, CCIE. It is everywhere. I can't say that after CCNA you don't need subnetting, or after CCNP you don't need subnetting. You definitely need it in all parts of your networking journey. Then if you are someone who is looking forward to get into the world of networking or trying to secure a job, we do have various programs which I would quickly like to show you. You can refer to them for maybe a good start in the networking journey. You just need to visit our website, pynetlabs.com. Here you can explore various programs that we offer, all the courses, all the technologies that we teach. And if you are someone who wishes to get placed as soon as possible, you are here to learn and get a job, then job guarantee is something for you. You can look into the job guarantee course. It is available for freshers. It is available for laterals. As per your technologies, as per your skills, you can select the appropriate program. You can see we have got it for network expert, for freshers and experienced. Similarly, if you wish to learn automation, we have got one for that. If you wish to do CCIE, we have got them for that. Advanced network automation and cloud. I mean, there are various options which can help you in landing onto job very easily, right? So you can definitely look through this particular page, which will guide you about what technologies are trending, how you can learn them, and if you wish to enroll into them, then you can definitely click on the Inquire Now option to get someone aligned to you. Lastly, there is also blogs that you can read to study more about networks. So yeah, that is also going to help you in skilling up. Thank you so much. That was all about this particular session. I can see that you guys enjoyed it. And thanks to you all as well for being interactive and participating in the webinar. We'll keep on bringing such amazing stuff on the YouTube channel. So if you are new, then do subscribe the channel. And thanks again. Bye-bye. See you in the next one. Take care. Thank you.